Okay, so what we're going to be talking about today is the real number system. Now this should be review. You guys have been talking about the real number system since junior high, so this should move very quickly. All right, by the end of this lesson, you will be able to identify various kinds of real numbers, use interval notation to write a set of numbers, identify the properties of real numbers, and find the absolute value of a real number. So again, all of this is review. We're going to move relatively quickly. All right, so here's just a little diagram as to what our number system actually looks like. We have our real number system, which encases everything, almost everything, and we'll talk about that a little bit later. So our real number the big rectangle here, okay? Inside the real number system, we have our irrational numbers. Now, an example of an irrational number we know as pi or square root of 2. Those are our quick, easy ones, okay? Inside my real numbers, I also have my rational numbers, my integers, my whole numbers, and my natural numbers. And we'll give examples of each of these as we go along. Okay? So moving on to the next page. Numbers that can be expressed in the form p over q, or p divided by q, where p and q are integers and q does not equal 0, are what we call our rational numbers. So they can be written as a fraction, essentially, is what we're saying. Decimal notation for rational numbers either terminates or repeats, so it ends at some point. It's a finite number. Below we have some examples. We have 0, -7, 1/4. Notice it can be written as a fraction and as a decimal. -5/11, or -0.454545, or you also know it written as this. Okay, and same thing below. We have 5/6, which can also be written as this. Okay, so these are all rational numbers. They're terminating. It can be written as a fraction or a terminating decimal. Okay. All right, real numbers. Real numbers that are not rational are what we call our irrational numbers, and we just talked about this a little bit. These are non-repeating, non-terminating numbers, such as pi, square root of 2, -6.121212221222. Yeah, I know that it shows a pattern, but this is not a rational number. Okay? All right, so when we combine the set of rational numbers with the set of irrational numbers, we create that big set of real numbers. This symbol here is used to show that a member or an element belongs to a set. We use this in place of this, okay, element. For example, we can say that pi is an element of the real numbers. So pi is part of the real number system. Or the square root of 2 is not an element of a rational number, because we know square root of 2 is irrational. So this would mean not an element. Okay. I think I have an extra or here we don't need. All right, so the symbol here is used to denote a subset. When all elements of one set are members of another set, we call that a subset. All right, so we saw this symbol here and this symbol here on the last page. So now we need to go back and think about what did those mean. So we could take a peek if we'd like. That funny looking Q is rational numbers, and the funny looking R is real numbers. So what this says is rational numbers are a subset of real numbers. Okay? That means every single rational number is also a real number. All right, so interval notation. Again, review. We spent a lot of time on interval notation last year, so we should be able to go through this pretty quickly. All right, for real numbers a and b, such that a is less than b, the open interval a, b is the set of real numbers between but not including a and b. So what this means is it's everything between a and b except for a and b themselves. We don't include a and b. So what this would look like on a number line is we're saying a is less than b, so a is going to be here and b is going to be here. this would look like on a number line. You see this written a couple of different ways. We looked at it as open circles with shading in between. You may also see it written as parentheses. You can see it written that way as well. Okay? And again, this means we're not including the values of A and B. So if you need a second to write that down, please do. Okay, so we're going to continue on. A and B represent endpoints on the interval. Parentheses indicate that the endpoints are not included in the interval. So we've already talked about this. We're ready to move forward. Some intervals extend without bound. For example, A to infinity. The bracket indicates that A is included, that square bracket, right? We're going to include the value of A. As we know, infinity isn't like a nice number that we see all the time. We can't put our finger on infinity, so that's going to use that open bracket. We're not going to include it. What that would look like on a number line is we've got our A, and we can't put infinity on a number line, so that's just going to extend off. And again, you can either use a closed circle and extend, or you can do a square bracket and extend. Either one is fine with me. Okay, so go ahead and write that down. And if at any point you need more time writing things down, please pause the video so that you can do that. All right, so we do have a bunch of variations of this notation in your that I'm going to have you write down into your notebook. So please make sure that you have that handy in front of you. All right, so our first one, is our open. And we talked about this. This is our A, B. They're open-ended on both sides. Okay, that's our set notation. This is our interval notation. This is our set notation. Interval, set. And then the graph for this, and I'll try and fit it all on here. I can't make any promises. AB and either open circle or parentheses. Okay. Closed. I'm sure you can imagine. AB. You're going to use your less than or equal to. And then closed. Okay. Half open. AB. So notice what's going with what here. That less than goes with the A and the less than or equal to with the B. All right. Open. Half open. Oops, I guess I should have an infinity sign here. I apologize. Open. And half open. Okay, so please make sure you pause here and get everything into your notebook so that you are aware of how all of these work. Okay, moving on. We're going to write the interval notation and graph the following. So we have -4 is less than x is less than 5. So in interval notation, we are going to use our open brackets. So this will be written as -4, comma, 5, and they're both having open brackets because we're not including the values of -4 and 5 on our number line. And I am going to switch up how I write this so that you guys can get used to seeing it both ways. -4, and I know it's not perfect, please forgive me. And we are going to use, this time, why not, our parentheses and shade in between. This states that -4 is less than x, which is less than 5. Okay? X is greater than or equal to 1.7. So everything greater than or equal to 1.7, that's going to go all the way to infinity. And because we're using the greater than or equal to sign, we are also using a closed bracket. And we're spreading that out all the way to infinity. And since infinity is not a number we can put our finger on, we're going to use that open bracket. So to graph that, I'm going to put our 1.7 on here. And I'm going to use a closed circle this time. Oops. Wait for that to go away. And it's going to extend to infinity. And there's our number line. Write the interval notation and graph the following. Okay, I'm going to leave the graphing up to you, and we're just going to go over the interval notation to move along a little bit here. -5 is less than x is less than or equal to -2. So this is one of those situations where I have both an open and a closed. My open is going to go with my -5, and my closed is going to go with my -2. Okay, moving on. Write an interval notation and graph the following. Again, I'm going to have you guys graph it on your own. Interval notation, we have less than, which means we're going to an open bracket. If I'm talking about less than, anything less than square root of 5 is going to go where? It's going to go all the way down to -infinity. And when we're writing in interval notation, we always want to make sure that that smaller quote-unquote number goes first. Okay? So we are going to use that open bracket. And since we're going all the way to -infinity, that's going to go first. It's smaller than the square root of 5. And there's our larger number. Close it off with an open bracket. Okay, a couple of properties. And again, we're going to go through this relatively quickly. I didn't want this video to run too long, so we're almost done here. Commutative property for addition. My commutative property for addition is going to be my a plus b, which is going to be the same thing as my b plus a. There's my commutative property for addition. Multiplication works essentially the same way. A times b equals b times a. Associative properties, addition. Associative meaning who you associate with, meaning how your parentheses are going to sit. So a plus b plus c, which is going to be the same thing as a plus b plus c. So again, if I had values in for a, b, and c, they would be the same on the left-hand and the right-hand side of the equal sign. Multiplication is going to be the same thing here. A, B, C, A, B, C. And it's all going to work the same. Okay. Additive identity. My additive identity is using the identity for addition, so what can I add to anything that won't change it? So my additive identity is going to be a plus 0, which, as we know, is the same thing as 0 plus a, which is just a. Okay, so my additive identity is 0. My additive inverse is what I add to any number that will give me my identity. So if I have a, what would I have to add to a to get my identity of 0? Well, if I have a, I need negative a. Okay, which is the same thing as negative a plus a. And if I have 2, and I add -2, what am I left with? 0.